नहीं नहीं हाँ हाँ can you hear me can you hear me Right. Okay then. Let's start. Can you hear me? Put in the chat. Can you hear me? Can you hear me? Yeah, okay. Okay, so today we are going to talk about the circulatory system, one of the most important systems in the Unit 5. Actually, the circulatory system has some specific points to remember. Number one is definition. Why do we need a circulatory system? Then we have to go into types of circulatory systems, single circulation, double circulation, those kind of things. Then you have to go into human circulation, and then we have to go into the heart. First, you have to learn the structure and function of the heart. Then you have to learn the conducting system of the heart. After that, you have to go into the cardiac cycle, right? I will stop at the cardiac cycle and I will start from the circulatory system beginning part. Okay, first, why do we need a circulatory system? What's the function of a circulatory system? Circulatory system is needed to transport materials within the body, which means this is you, let's say. You need a circulatory system to transport material throughout your body. Otherwise, who will do it? Right? And is it enough transporting within the body? Not enough, right? You need to like re-energize because your resources are used in your body and the waste products are created. So you need to put out the waste products and get in the pure ones. So this is taking place with the external environment. This is taking place with the external environment. So the definition goes like this. A circulatory system is required for animals for transportation of materials within the body and exchange of materials with the external environment. So transport of materials within the body and next one exchange of materials with the external environment. Right. That's it. Now you have types of before that there are substances that are transported in the circulatory system. What are they? You need to know these, okay? Now I will after this session I will put my flashcards on circulatory system. There are like more than 30 or something flashcards are there for questions, for simple questions. Like the first question is why do we need a circulatory system? The second question is what are the materials transported within the circulatory system? Likewise. So the second question goes to this one. What are the types? What are the things transported in the blood? Respiratory gases, nutrients, waste products of metabolism, hormones and antibodies. There are five things that are transported in the blood. What are they? Respiratory gases, nutrients, metabolic waste products, hormones and minerals. Hormones and antibodies. Right. So next we have the blood circulatory system of animal kingdom. Right. Animal kingdom, blood circulatory system. So here also there is a question. What are the three basic components of circulatory system? What are the basic components of circulatory system? What do we need to make a circulatory system? So like, what do we need? There are three things given in the resource book. They are the muscular pumping device, the heart. This is the muscular pumping device. Then number two is interconnected vessels. Number three is circulatory fluid. You need all these three things to make a circulatory system. Right. Next. Types of circulatory system. Right. What do we have in the types of circulatory system? I will draw a graph, not a graph, like something like this circulation in animals. First we have open circulatory system. I will take it this side. You have the open circulatory system, and on this side you have the closed circulatory system. Right. Then in your resource book, they have divided the closed circulatory system into two types. What are they? Single circulatory system, single circulation and double circulation. They have divided the closed circulatory system into two types, single circulation and double circulation. Meanwhile, the open circulatory system is not divided into anything, and this is related to cockroaches, okay, arthropods. This thing we can divide into this is single circulation and this is double circulation. Right. So here, what do we have in the open circulatory system? What do you need to remember in the open circulatory system? What do you have to remember? You have to remember the definition of open circulatory system, and you need to know the animals having the open circulatory system was questioned, very questioned in the what that structured essay questions. They have questioned very often that these things, the organisms who do double circulation, organisms who do single circulation, organisms who have open circulation, they have questioned. So here, what is open circulatory system? Right. It is a circulatory system in which fluid called hemolymph. Why it is called hemolymph? It's different to blood. And it is same as the interstitial fluid. Hemolymph is same as the interstitial fluid. So what's the definition? It is a circulatory system in which a fluid called hemolymph that bathes organs and tissues directly. Be specific with the words, okay? Be specific with the words. Bathes the tissues and organs directly, which means like what? If I draw open circulation, something like this will come. Let's say I have a diagram for that. Organ and cells. Right. So what happens here? The heart has a valve. They have said something called as a different heart is there. Right? Let's see what they have done. There is no distinction between the circulatory fluid and the interstitial fluid surrounding the cells. The heart pumps hemolymph through the circulatory vessels into the spaces which surround body tissues. Chemical exchange occurs directly between the hemolymph and the blood and the body cells. Backflow of hemolymph takes place via pores with valves found in the heart during relaxation. This is the pore which they are talking about. This is called ostia. This is called ostia, and this is the heart. right? So all this fluid is called hemolymph. All this fluid is called hemolymph. All this fluid is called hemolymph. Give me 1 second. Right. Sorry about that. All these are called hemonymous. So the open circulatory system looks something like this. Right. And then you need to know the animals having the open circulatory system, very easy. Arthropoda and mollusca, they have said some mollusk groups only. Right. You need to know two things. The definition you need to know, and Anna, you need to know three things. The first one is definition you need to know, and then next one you need to know this ostia thing you need to know, prevents backflow of blood. Then you need to know the animals having the open circulatory system. The animals having the open circulatory system are arthropoda, arthropods, and mollusks. Done. Right. Now we're moving to this side. So this side is over, and we are going to the other side, the closed circulatory system. There's a definition for that also. That also you need to remember. Sorry.com. We have a lot of definitions to memorize in this lesson. What is closed circulatory system? It is a circulation in which blood is restricted to vessels and kept apart from interstitial fluid. Right. In the previous one, interstitial fluid and the blood are same. Like there's no difference, and they were commonly known as hemolymphs. But here, things are different, and they are separated. Blood is separated from interstitial fluid by vessels. Now in humans also same thing. In the vessels, blood is flowing, and outside the vessel, it's called interstitial fluid, and it's not blood. If you think like it's blood, it's not blood. Okay, the what is going inside the vessels are called blood, and outside the vessels are called interstitial fluid in the tissues. Right. That's the definition. You need to know that. Then they say blood is pumped by heart into large vessels. These large vessels branch into small vessels and penetrate into the organs. They are talking about capillaries. Okay. Chemical exchange occurs between the blood and the interstitial fluid and body cells. Okay. It may contain one or more hearts. They can ask this in MCQ. They can ask like in closed circulation, animals only have one heart. That's wrong. They say one or more hearts. One or more, right? This type of circulation can be seen in it may contain one or more hearts. One or more hearts. Highlight that. They might ask an MCQ like animal and in closed circulation, organisms have only one heart. That's wrong. One or more hearts. Right. Let's see what's next. This type of circulatory system can be seen in vertebrates and invertebrates. This type of circulation can be seen in whom? Vertebrates and invertebrates. Within brackets annelids. Such as annelids, okay? Such as annelids, they say. In comparison to open circulatory system, this enables effective delivery of oxygen and nutrients to the cells of larger and more active animals due to relatively high blood pressure. Now this one, what is happening here? Nothing is happening here. The like it's very static. This guy is pulling hemolymph, and from the other side it's coming out. Something like that. So in here it differs. And the exchange of material oxygen takes place. Yeah, I forgot to name that. Respiration is taking place here with the external environment taking place on that side. Then here, closed circulatory system, it differs. How does it differ? Because in the blood vessels, when you like, okay, let's think like you're spilling water onto the ground like this. Okay, now if you keep your finger on the other side, if you do like this and you keep your finger on the other side, the pressure you feel is less. But if you take this bottle into a pipe or something and you hold it like this, you will feel a greater pressure, right? Okay, that's what they're saying. This enables it to have higher blood pressure. Done. Next, we divide this into two: single circulation, double circulation. What is single circulation? Okay, that also have a definition. You need to remember that also. What's the definition? Single circulation. In a complete circulation through the entire body, blood passes through the heart only once. Okay, repeat. In a complete circulation throughout the entire body, blood passes through the heart only once. That's it. In animals that demonstrate single circulation possesses two chambers in heart, the atrium and the ventricle. Right? There is no only atrium, there is no only ventricle, there is both atria and ventricle. During single circulation, the oxygen poor blood, and they have said the procedure. Okay, I won't go through the procedure, you know the procedure. It comes to the atrium, then to the ventricle, then pumped, then goes to the respiratory system, then exchange of oxygen takes place, that thing happens, then oxygenated blood reaches to the whole body, something like that takes place. You can look at the diagram on the other page. They have given in the Rankers Club group. I have put the diagrams and all. You can like watch them, look at them. I put it in the morning, I think. And somebody is selling things, right? I made a group to them also. Very funny. Okay. Then double circulation. Now, but before that, single circulation, animals you need to know. Bony fishes, cartilaginous fishes. Single circulation, this is the only thing you need to know. Bony fishes, and this definition you need to know. Bony fishes, cartilaginous fishes, such as rays and sharks. Such as rays and sharks, not whales, cartilaginous fishes such as rays and sharks. Rays and sharks, only rays and sharks. Do not like think like whale also have. They have double circulation. They are mammals, right? Then focus. Double circulation. Double circulation also have a definition. What is the definition? Right. The same thing, okay? They are saying in a complete circulation throughout the entire body, blood passes through the heart once in the single circulation, and here twice. That's it. And then you have to remember such circulatory system, pulmonary and systemic circuits, right? Pulmonary and systemic circuits. What does it mean? Pulmonary means what? The name pulmonary. Pulmonary means related to the lungs. Pulmonary system is where the blood passes through the lungs, then get oxygenated and comes back to the heart. You know that, right? You know it. Pulmonary system, pulmonary and systemic circuit, in which blood passes through the heart after completing each cycle. They have given some animals. Focus them. Amphibians, reptiles, apes and mammals. Amphibians and most reptiles have three-chambered heart two atria and one ventricle, and birds and mammals have four-chambered heart, where heart is completely divided into left and right sides. Okay, there's a short note for this. In common, they say amphibians, reptiles, aves, and mammals have double circulation. Amphibians, reptiles, aves, and mammals. Amphibians, reptiles, aves, and mammals. Amphibians, reptiles, aves, and mammals have double circulation. Then they say some have three-chambered heart and some have four-chambered heart. Now, who have three-chambered heart? Three-chambered heart. Four-chambered heart. Three-chambered, four-chambered. What are three-chambered hearts? They have given two examples: amphibians and reptiles. Amphibians and reptiles, and four-chambered heart. You can have birds and right. This is all you need to know. Nothing else you need to know. You have to know that double circulation is more effective in pumping blood than the single circulation. Now, if you are writing an essay from this, you need to know everything. Okay. Now, don't tell that there is too much. You need to study. That's biology. You have a task in your hand, and if you can't do it, you're not good to be a doctor, right? A doctor should memorize a lot of things than just these few books. And like this is just a very small thing for very small thing. If you like repetitively do it, you will have the chance to complete this. Complete the whole book. Right. If you want, you can draw this or write this. I will give you 1 minute. Or take a screenshot. You can have you will have device. Take a screenshot. It's not 19th century. I will erase this now. Right. In the next part, there's nothing to tell, right? Right. Next they have said the basic plan of human blood circulatory system, and it is the way the blood flows. Okay. Before telling that, I will go into the structure and function of the heart. Right. Our lymphatic system is there. Oh, I will do lymphatic system after that. The heart is important. Right. How to draw the heart? This is the one I need like marketing in the morning. How to draw the heart? How to draw the heart? How to draw the heart? Very easy. You just draw two lines. Draw three lines. One like this, one like this, and another one like this. Close like that. Okay. Then you complete this tube-like thing up to here. Then another tube like this up to here. Right. Now you draw like this. Then you complete the ball of the heart. Then you erase this, okay? You can't keep this. This line you need to erase. Then you draw this one. You come down. Then you need to connect like this. Open the div. Then other side also same thing. Be careful when you draw the left ventricle thicker than the right ventricle, okay? Then you need to do like this. It's better if you can move this closer. It's better if you can move this closer. Then opening into the, here is the superior vena cava and down inferior vena cava. This is inferior vena cava. Now is the labeling only. Yeah? This is the superior vena cava. Then this is the left right pulmonary. Right pulmonary artery. Sorry, vein. This is the left pulmonary vein. And then this is the this one important thing in Sinhala the two and Vama is there, right? This is not Mama, okay, Vama. Vama. So Dakuna means three. Three letters are there, 1, 2, 3 letters. So right side is the tricuspid valve. Tricuspid valve. And on the left side is the bicuspid valve. And on the other side is bicuspid valve. I'll erase this now. And then you need to name the ventricles. These are the left ventricle. This is the right ventricle. This is the before that let's see. Right atria, left atria. This is the right atria. Then this one is the which is coming from the left atrium is the aorta. This is the aorta, and this is the pulmonary artery. What else? What else? What else? What else should we name? That's all, right? If you want, you can name myocardium, endocardium, and pericardium. No need. That's all. That's how we draw the heart. That's how we draw the heart. Then you need to go through the things written in the resource book. You need to memorize everything. You need to write it. I hope you are good with the heart one. The human heart is roughly a cone-shaped hollow muscular organ. The wall is composed of pericardium, myocardium, and endocardium. Then pericardium is divided into the outer fibrous pericardium and inner serous pericardium. Right, you can study those things, right? I will give an essay from this. From the heart, you can write a complete essay on the structure and function of the heart. You need to draw this also. Right. Then I will go into the conducting system of the heart. conductive system of the heart. What's that? Right. Yeah, it's a nice diagram to draw here. And draw the heart. They say there is something like a not non-conducting thing here. You don't need to know the name of it. They call it the fibrous annulus. You don't need to know the name. They haven't given me the resource book about that. Then there is your favorite thing, essay note. I don't know your favorite. It's my favorite. There is the green color one. There's no green color one. Here it is. What is this essay note? This is the essay note. It transmits the electrical impulses throughout the atrium. Like this. Then you have this. It comes down like this and divides into two. Divides into two and then break down into fine fibers down here. Right. Now we have to name this. This is atrioventricular node. Atrioventricular node. This is the what? Sino-auricular node. SA node, AV node. This is the AV node. AV node, SA node, AV node. Right atrioventricular bundle, left atrioventricular bundle, left atrioventricular bundle, right atrioventricular bundle, left AV bundle, right AV bundle. Left AV bundle, right AV bundle. Then the left AV bundle divided into fine fibers known as the Purkinje fibers. These are called the Purkinje fibers. These are also called the Purkinje fibers. Right. Then right atrioventricular bundle, left atrioventricular bundle, AV node, fibrous annulus is there, then that's all. Now what happens when blood flows into the right atrium? When blood flows into the right atrium from the superior vena cava and inferior vena cava, this thing is stimulated. What is this? SA node. SA node stimulates. You need to mark the aortic valve and the pulmonary valve too. Yes, you need to mark the aortic valve and pulmonary valve. It's more good if you can name it. Right. Then SA node stimulates and then the signal transmits into the AV node. From the AV node, it moves through this non-conducting thing. So the signal won't pass from here to here, okay? Because of this fibrous annulus, it won't pass. It will stop from here, but passes through this into this and then into the ventricle. This electrical impulse causes the muscles of the heart to contract, which pushes the blood out of the ventricles into the aorta and the pulmonary artery. Right. Then that's also conducting system. You can combine the things in the resource book with this one. Then after that we have the cardiac cycle. Then we have a cardiac cycle. This is like pure understanding. Okay, let's take what is cardiac cycle. There's a definition. You need to know the definition. Cardiac cycle refers to a sequence of events that takes place in a complete heartbeat. You need to know it. During this process, one complete cycle, pumping and filling of blood into the heart occurs. Obviously, complete cardiac cycle lasts for 0.8 seconds. What is the total cardiac cycle? 0.8 seconds. Not a perfect circle. Let's see. I can't do it. Almost perfectly. It's not coming. Okay, cardiac cycle lasts for 0.8 seconds total. 0.8 seconds in total. Then there are three paths. There are three things. What are they? The atrial systole, the ventricular systole, and then the complete cardiac diastole is there. Right. Atrial systole means contraction of atria. Atria. Same thing. Then ventricular systole, same thing. Ventricles contract for ventricular systole. Then complete cardiac diastole, relaxation of atria and ventricles. Okay. What happens? This is the atria. These are the ventricles. Like this. Atrial systole, ventricular systole, complete cardiac diastole. Atrial systole, ventricular systole, complete cardiac diastole. Right. They say at rest the adult heart is likely to beat at 60 to 80 beats per minute. What is the rate of the heartbeat? 60 to 80 beats per minute. Right. During a single heartbeat, the heart contracts and then relaxes. During single circulation, the amount of blood pumped by the ventricle is called stroke volume. What is that? During a single contraction, the amount of blood pumped by the ventricle. Right. This is the ventricle atrial systole, then ventricular systole. The amount of blood leaving the heart by pumping of the ventricle is called the stroke volume. There's another definition. That's the definition of for stroke volume. You need to know it too. Right. Then they have divided. Right. First, you have the complete cardiac diastole. Complete cardiac diastole, CCD, I'll write it. Then they say this lasts 0.4 seconds. 0.4 seconds. What happens? Relaxation of both atria and ventricles takes place. Right. When the atria and ventricle relaxes, what happens? When atria and ventricle relaxes, blood from the blood from the superior vena cava and inferior vena cava, and blood from the pulmonary veins empty into the atria. What happens? Blood from the superior vena cava, inferior vena cava, and the pulmonary veins empty into the fill into the atria. Blood fills into the atria, obviously. Then what happens? After that, what happens? The valves are open. Who said the valves are closed? Valves are not closed. Valves are open. Now what happens? When the blood is filling into the atria, some of the blood flows into the ventricles. When the blood fills, when the blood comes out from this side, this side, this side, this side, everything comes and falls into the atria. Then some of the blood moves into the ventricles. That's what they have said. The pressure of atria is more than the pressure of the ventricles. Therefore, atrioventricles are open, and some blood passes passively through the ventricles, through to the ventricles. Some blood passes passively. Okay, this is passive. Not the full ventricle is filled here. Something like this, small amount is filled. Like this, which happens. Let's say like you you put some water into here. Some of the water will pass down. It's obviously it's happening like due to gravity, it will fall down. Same thing here also. Right. Then you have the atrial systole. From here to here, atrial systole. This lasts for 0.1 seconds. What happens? Now they have said when blood flows into the atrium, SA node is stimulated. Then the SA node triggers a wave of contractions that spreads over the myocardium of both atria. Hence, the remaining blood in the atria flows into the ventricles, thereby emptying the atria. This lasts for 0.1 seconds. Right? What happens? When blood flows into the atria, the SA node is stimulated. You need to know the location of the SA node. Very important. You need to know the location of the SA node. And SA node is stimulated and triggers a wave of contraction that passes through the atria, and atria contracts. Now what happens? Blood directly flows into downwards direction, and the atria is contracted. Right. Then ventricular systole. What's that? Through the atrial muscles, the electrical impulse reaches the AV node. That time I drew a diagram, I erased it. Through the AV, then to the AV node, then the AV node triggers its own electrical impulse. Okay, that original electrical impulse is not passing into the ventricles. Okay, now it's like this. Somebody is running. Okay, now one person is standing here. One person is standing here, and other person is running. He's running and coming to you and telling a news, something else. Okay, then you're not taking his energy, right? You're making your own energy and you're running. That's what happens here. Here also they say the AV node triggers its own electrical impulse, which then quickly spreads to the ventricular muscles via the AV bundle branches and Purkinje fibers. This results in wave of contraction which sweeps up from the apex of the heart across the wall of the ventricles. As a result, the both ventricles contract. Patta clear? Right. The pressure in the right ventricle is more than the pressure in the pulmonary artery, and pressure in the left ventricle is more than the pressure in the aorta. Therefore, pulmonary valve and aortic valve are closed. Pulmonary valves and aortic valves are open. Sorry, they are open because the pressure is greater. Now this is physics. Okay, the place where the pressure is greater, the valves are getting opened. So that's what's happening here. Right. Then next, the pressure in the right ventricle, I said it. Then they say like valves close and open, and that makes this thing work. Valves, opening and closing of the valves make the cardiac cycle function. That's what they say. And you need to know this one. Atrial systole, ventricular systole. This is 0.3 seconds. That's it. Whew. Then you have let's go into the electrocardiogram. Let's go into the electrocardiogram ECG. It's not being like this. Like this, like this. Something like this. No. I forgot the T. This is taller than this. This is taller than this. This is PQRS. PQRS. Oops. QRST. And the S and the Q are in the same level. You need to know this, okay? I don't remember this. I mean, now I don't remember. I remember when I'm going to the exam. Now it's like how many days now? I can't remember everything. PQRS T. This is 0.8 seconds. This whole thing is 0.8 seconds. Right. PQRS. PQRST. Then P wave. It represents the impulse from the SA node as it sweeps over the atria. Right. P wave. SA node stimulation. SA node stimulation means atria. Right. If I say like this, the heart. Let's take the heart again. Okay. Then I will say PQRST. PQRST. Repeat with me. PQRST. Something like that takes place. Right. P wave is the SA node stimulation, the atrial depolarization. Then QRS wave represents the rapid spread of the impulse from the AV node throughout the ventricles and the electrical activity in the ventricular muscles, ventricular depolarization. PQRS. Then T wave represents the ventricular repolarization and relaxation of ventricular muscles. Due to larger QRS wave, the repolarization which occurs during the ventricular contraction is not seen. Information about the heart function of a person, state of myocardium, and the cardiac conduction system can be obtained by examining the pattern of the time interval between the cycles and part of the cycles. I have taken an ECG like 4 years ago, maybe. Like something was wrong with the heart, not heartbroken. Okay? Something was wrong with the heart, and like I had to take an ECG, and they said nothing was wrong. That's the like funniest thing ever happened. Okay. Then basic plan of the human lymphatic system. Lymphatic system. What is this lymphatic system? Lymphatic system, there's a diagram, I need to draw it. Should I draw it? Not knowing everything. Okay. Lymphatic system is closely connected with the blood circulatory system, both structurally and functionally. You need to know this paragraph, okay? They'll ask for short notes and stuff. You need to know this paragraph. The lymphatic system is closely connected with the blood circulatory system, both structurally and functionally. It consists of, lymph vessels through which lymph travels. Other than that, there are lymph nodes, lymphoid tissues, lymphoid organs, and lymphoid organs. Lymphoid organs such as spleen and thymus. One more thing. First, you have lymph vessels. Lymph vessels are there. Lymph vessels are there. Then you have the lymph nodes. Lymph nodes. Then third one you have lymphoid tissues and lymphoid organs. Lymphoid tissues. Lymphoid organs. Right. Lymph vessels through which lymph travels, lymph nodes, lymphoid tissues. Lymphoid tissues are tonsils. In your throat. They are what grows when you're getting sick, right? Tonsils and lymphoid organs such as spleen and thymus. Lymphoid organs such as spleen and thymus. Spleen and thymus. My letters are not clear, okay? Like this is my handwriting. I know it. Right. Then lymph vessels consist of tiny vessels and large vessels. We are filling the information. Tiny vessels, and you have larger vessels. Tiny vessels and large vessels. Tiny lymph vessels are in close contact with the capillaries of the blood circulatory system. Close contact with the capillaries of the blood circulatory system. Lymph nodes are composed of connective tissues and white blood cells. Connective tissues and white blood cells. Connective tissues and white blood cells. Right. The lymphatic system returns the lost fluid and proteins from the blood capillaries back into the blood. Okay. Lymphatic system. What is the role of the lymphatic system? Lymphatic system is there, right? Let's say the blood circulatory system is this one. Then materials are coming like this, and putting out here. They are only taking 90%. They can't take, they don't take everything. They are like, we don't take 100%, we take only 90%. You can stay there. Others are letting to stay here. Now what happens? Now tissue fluid is accumulated here. Tissue fluid is accumulated here. Tissue fluid is accumulated here. Now who's going to take this out? Who is going to take them out? If nobody takes them out, you know what happens? You know that disease is there, like Barba or something. In that, the legs and all getting swelled, then your hands get swelled, then your face gets swelled. Those things getting swelled because of accumulation of tissue fluid. This is tissue fluid. I said that inside the blood vessel it is called the blood. Outside the blood vessel it is called interstitial fluid, also known as tissue fluid. Right. Who is going to take them out now? There is something called lymphatic system. Tissue fluid is getting into these lymph vessels and then transport back into the blood circulatory system. That is what the lymphatic system does. Right. Let's see. The lost fluid in blood capillaries is called lymph when they are inside the lymphatic system. Now make sorry. When this comes in, it is called the lymph. Outside it is called interstitial fluid. Inside this it is called blood. The same person have nicknames, like when you go to your school you are called by some other name, and when you come to home you are called by some other name, and when you go to professional place you are called by some other name. Likewise, it differs. So this guy inside the lymphatic system is called lymph, so it travels through the lymph to the lymphatic system known as the lymph. Right. The composition of lymph is same as the interstitial fluid, we know that. Then lymph vessels have valves which drain the backflow of the lymph. Right. Now when you're climbing a ladder, what prevents you from falling down? Those steps, right? Those steps are there which prevents you from falling down. So likewise, here also there are something called valves. Like this, valves are there. So then ගිහිල්ලා ආව කරන්නේ මොකද ඉස්සර යන්න මේක we can nothing. Okay, then Then what do we have next? Prevents the backflow of blood, backflow of lymph. The lymph is drained into veins at the base of the neck, right? At the base of the neck, we have two large ducts. ඒකට කියන්නේ thoracic duct and the right lymphatic duct. Thoracic duct and right lymphatic duct. You don't need to know the name, right? You need to know only they are drained at the base of the neck. We have two large ducts, and you need to know it is drained into a vein. Okay, not something else. It is drained into a vein, not an artery, because vein has less pressure than the artery, so it is easier to put something in, right? Then the functions of the human lymphatic system include tissue drainage to maintain the blood volume in the blood circulatory system, absorption of fat and fat soluble vitamins from the small intestine, and immune responses. Those are the functions of the lymphatic system, right? That's all for today. That's all. Circulation system 1 hour 7. I mean, yes, that's all. Nothing else. I said only up to the ECG, we are in cardiac cycle. So here we go. I'll put the recording in the group. So thank you for joining, and I think I will end the meeting now. Okay. Thank you.